Hello, so let's just dive right in. For this tutorial, I will be using Autodesk Fusion 360, but the principles that I talk about in this tutorial apply to any CAD software out there. So first, let's talk about the basic commands for designing parts and making your first project. So in CAD, how it works is that we always start from 2 dimensions and then we make that 2-dimensional figure into 3 dimensions. So first, to design in 2 dimensions, we create a sketch. So I'll be clicking this create a sketch button and selecting the XY plane. Once I do that, I created a sketch. Now you can use these tools up here to essentially make any 2D figure. So let's say I want to make a, let's make a square. Now I made an arbitrary square right here, and if you want to basically alter the dimensions of your square, you can use this tool, which is known as sketch dimensions. So voila, let's make it. Yeah, I think 5 centimeters is a pretty good amount. So 5 centimeters by it's already 5. So 5 centimeters by 5 centimeters. So now we have a square. So that's good enough for me. I'm gonna say finish sketch, and now we have a square in 2 dimensions. Now let's say we want to make this square into a rectangular prism. So how do you make this 2-dimensional square into a 3-dimensional figure? For that, we're going to be using the extrude tool. So I'm going to select that tool, and the face is already selected, and then I can use this arrow to essentially pull the square out into a rectangular prism. So I'll make it about, let's say 10 centimeters. I want it 10 centimeters tall. Okay. So now I have a new body. But let's say we want to make this square or this rectangular prism hollow, somewhat like a metal beam. So we can create another sketch on top of the square, and then let me make a square inside of the square. Once again, I'm going to use the sketch dimension tool to make the distance between the two squares about 0.2. So I want to make the thickness of this beam 0.2 centimeters or 2 millimeters. Okay. Now that I created my square on top of this rectangular prism, I can once again use the extrude tool, select that, and then instead of new body, you can select cut, and then pull this arrow down, such that it digs right through the square. Boop. Voila. So now we have a rectangular prism. Let's say on one side of the rectangular prism we want to make a bunch of circular cutouts, where rivets or screws can fit right through. So first, I'm going to create a sketch on the side we want to make the cutouts. Next, I'm going to select a circle, and I'm purposely just going to make it off-centered so I can show you how to fix it and make it centered. So let's say I want the diameter of the circle to be, let's make it 7 millimeters. Okay. Now first, we want all the circles or cutouts to be in the center. So how do we do that? Remember, the dimensions of this outer square is 5 centimeters by 5 centimeters. So we can use the sketch dimension tool, select the outer boundary of one square and the center of the circle. And 5 divided by 2 is 2.5, so I'm going to enter 2.5. And voila, centered. We got the first thing out of the way. Next, you could imagine, well, we could just go through and make a bunch of circles, but that would be really tedious. So what I'm going to do is I'm just going to finish the sketch. And so now we have a little circle on top of this rectangular prism. And I'm going to extrude it. I'm just going to go ahead and extrude it. I'm going to select the symmetric extrusion such that when I drag one arrow, it extends in both sides. Like this. But right now we're cutting. And I don't want to cut. Even though the end intention is to cut out the hole, right now I'm going to make a new body, so it'll kind of look like a peg, representing the screw that we want to put into the hole. So yeah, I got the peg, and it's going right through. Now we can use one of Fusion's or any other CAD software's nifty tools, such as pattern. So for this, I'm going to be using the rectangular pattern. So body, I'm going to select this little peg body we just made. And for direction, we want to go along the z-axis because we want to have a bunch of these going down. So I'm going to select the z-axis. And yeah, I just want them going down like this. And if I want more than just 3, I can just use this arrow here, right here, make it multiple. I think that looks like a good amount to me. What do you say? Going about 8.5. That's good. So yeah, now we have a bunch of pegs going through here. Now what you can do is we can use the combine tool, and instead of joining down, we cut. So what we do here is that we select the main square as the target body, and as the tool body, so we select all of these individual pegs. Okay, so now that we have our parts, let's say you have multiple parts, and you want to put the parts together to make a larger part or an assembly. So first thing you want to do is you want to save this. So I'm just going to save the part in part 1, and I'm going to make a new file. Let me save this file as, I'll name it assembly, or part assembly. So I have this new file for part assembly, and what I can do once it stops loading is I can insert the part into the current design, and voila, so we have the part that we made earlier into this new file. We can use these tools to move it around. You can use these to rotate it. So yeah, we have a part. Let me insert another one of these. Oof, look, now we have 2. So let me just rotate this just for fun. No rhyme or reason to what I'm doing right now. Alright, so we have these 2 parts, and let's say we want to connect them somehow. So this guy needs to first be rotated or moved in the orientation that we want to connect them in. So to rotate or move things, we can use the move/copy function. Select on the component that we want to move. So this is the component. I'm gonna select on it, and then I can rotate it. So the way I want to connect them is I want to connect them such in a 90-degree angle, such that this guy is attached to the bottom of this guy. Now how do we do that, you may ask? And for that you need to use joints. Depending on whatever software you're using, they can be called joints, mates, anything of that nature. So I'm going to be using a joint, and I'm going to be using just a regular simple joint. So the way it works, you want to align the 2 parts together. So I'm going to be aligning the bottom corner of this part with the bottom corner of that part. Select it, and the parts just made it to make an L. Alright, so now that we went over the basics, we can use this information to help make more complicated parts. So I'm going to quickly go over how to make a propeller, because that was specifically relevant to my research at the academies. So I've created a new file, and let's start off with creating a sketch. Like I said, the most basic thing that we'll do. For this, I'm going to make a straight line starting from the origin, and I think I want the length to be about 1.2 centimeters, and I'll angle it about 40 degrees above the x-axis. Awesome, so now we got our first line. Now I'm going to use something called a slot, and a slot is essentially just like, it's like a oval, but it's linear. I'll show you. So I'm going to select a 3-point arc slot, select the 2 endpoints, and just place this wherever I want. And so this is what a slot looks like I was saying. Like a Cheeto. It looks like a Cheeto. So I want the diameter of my slot to be... let's make it 0.47, so 4.7 millimeters. Awesome, so now that we got a slot, I'm going to use the sketch dimension tool to alter the radius of curvature of the slot. It's a little too curved right now, so I'm going to make it 2 centimeters. So how I'm going to go about creating a propeller is I'm going to start with by making one propeller blade and then adding on to that propeller blade. So right now I'm going to make a bunch of different cross sections of the propeller blade, And then once you have a bunch of two-dimensional cross sections, we can combine these cross sections to make a three-dimensional propeller blade. So we got our first cross section done. Let me make my second cross section by using the construct tool. And oops, I clicked the wrong thing. Construct. I want to click this plane. And what I'm doing here is actually super cool. What we can do is we can make our own planes. So I want to make a plane that is parallel to the XZ axis. I want it to be offset by about, let's make it 0.75 centimeters. Alright, so now we got our new plane. I'm going to create a sketch on this new plane. Once again, quickly, I'm just going to make a new cross section. It's going to be pretty similar to the older cross section. So, and I want this cross section to be a little ahead of the other ones, so I'm going to use sketch dimension, make it about 0.1 centimeters ahead. And then I will once again use my slot tool, 3-point arc slot. And my sketch dimension tool to alter the radius of curvature. Voila, 2 cross sections done. Alright, so now let's make the next cross section. Once again, I am going to make a plane that will be parallel to the old plane, and I want this plane to be about 4 centimeters ahead of the other plane. So yeah, got this new plane, create a sketch, boom. I want to start off with a line like usual. Put the end of the line here, put it over there. I want the angle of inclination of this line to be 20 degrees. Voila. Okay, now I'm going to use the sketch dimension tool to make sure that the line is how long I want it to be. I want this line to be 3 centimeters long. So, ta-da, 3 centimeters. Now, I want to alter the location of this line with respect to the origin. So, I think I'm going to have it... I'll have the distance between the back and the origin to be about 1.5 centimeters. So that, and then I want the back to be also about 0.3 centimeters below. So put that there, 0.3. Now there we go. We got our line. Alright, like I was saying, once again, I'm going to rely on a slot, but this time I'm going to be using a center-to-center slot. I will be selecting the end of this line, this of this line, and I want the diameter of the slot to be 0.4 or 4 millimeters. 0.4, enter. Yay, so now we got 3 cross sections. I only want to do about 2 more cross sections until we're done. Don't want to make this too long. Construct, plane, ta-da. Let's make this one 11 centimeters away. New sketch. I want to make the sketch on this plane. Zoom, zoom. Alright, line. Now, once again, I want to make this line start below and to the left of the origin, just like we did for the other one. So I'm just going to do something like this. I want this line to be 10 degrees, inclined about 10 degrees, like that. I want it to be... how long should we make this line? I want it to be 0.8 centimeters long. Quite a small line if you can tell based on the other lines. Now let's adjust its position relative to the origin like we've been doing. I want it to be... I want it to be 0.07. And I want this to be 0.4. Then I'm gonna head over to, once again, we're gonna use the center to center slot, select the ends, and select a proper diameter. So I think a good diameter should be, I'm sorry guys, I'm making this up on the fly, so I've got a lot of thinking to do. About maybe 0.3 should be fine. Alright, yeah, 4. I think I'll make it one more cross section. So, finish sketch. My computer is lagging. I think I'm lagging as well. Okay, so select this plane. Bada bing, bada bang. I want to make this 12.1. I don't know, 12.1 sounds good. I'm gonna create a sketch on this. Yeah, I want a line. I want the line this time to be like that. Yeah, I want it to be about point. Let's see how long. Yeah, 0.4. I want to make it about 0.4, and I want it to be directly above. And I'm gonna use sketch dimension to make its height above. I want to make it about 0.22. 0.22. Okay. It's a little higher. 0.22, 2.2 millimeters. So I'm gonna then head over to the slot option like usual. Center to center slot. I want to make the slot have a very small diameter, not the important 0.1s. It looks like it's pretty cool. Yeah, 0.1. This is 0.4, so let's make this 0.15. Finish sketch. Okay. Alright, guys. We got a bunch of cross sections here. Okay, so now that we got all of our cross sections done, we can start by making these two-dimensional cross sections into the three-dimensional propeller that we eventually want to create. So in order to do this, I'm going to start by creating a sketch like usual, but I'm going to make a 3D sketch. So here I'm going to select the 3D sketch feature. Now I'm going to be selecting spline. Spline, 5-point spline. So using the spline tool, I'm going to be selecting the fronts of every single one of these cross sections that we made. Just like so. Awesome, so now that we got the front of the propeller done, I'm just going to select on this green line over here, and essentially what I'm going to do is I'm going to apply a constraint, and what this constraint does is that it makes it either parallel or perpendicular to the x or y axis, whatever axis is closest to. So yep, apply the constraint, and it's going to alter the shape just a little such that the front of the propeller is flat. Alrighty, so once again I'm going to be using the spline, so I'm just going to make sure I select the right spline. We're going to be using a 5-point spline to define the rear end of the propeller. So once again, I'm just going to select the rear end of the cross sections. And when you're using cross sections to define a three-dimensional figure like what I'm doing, it's important that you use the spline and select on the points of the cross sections where a triangle appears. Alrighty. So now that we got our propeller blade, we can start using extrusions, or lofts, to make this propeller blade into a three-dimensional figure. So you can kind of see what the propeller blade looks like right now. Now I'm going to use the loft feature, which is, you can see over here. And what the loft feature does is that it essentially combines cross sections using guide rails. So I'll show you what we're doing. So I'm going to first select all my cross sections. 1, 2, 3, 4. You can see what it's doing. It's trying to combine all of these cross sections, but it's messy. It's not within the borders that we made. So now what we can do is we can select rails, and we can tell it only color in between these two rails that we made. So I selected the rail. Let me go to the front. Select the front rail. Zoom out and see what we made. Wow, that looks awesome. And yep, that looks good. Click OK. And now we got a propeller blade. With the first propeller blade done, we can now start to work on the rest of the propeller. So first, I'm going to start making the central hub, where the motor or anything else attaches to the propeller. So that's usually, it's a circle. I want mine to be about 1.7 centimeters in diameter. And we need a hole in the center, and I want that hole to be about 0.5 centimeters. Alright, so you got a sketch of the central hub. I'm going to finish this sketch. And now I am going to use the extrude tool that we have shown earlier to extrude this hub and make it a three-dimensional figure. Now first, I want the direction to be two sides because I want it to also go a little lower. So I want it to go, let me make this into a new body command instead of a cut command. So I want the extrusion upwards to be about 1.2 millimeters. So just edit that, 1.2. And I want the extrusion going downwards to be about 0.35 centimeters. So awesome sauce. So now we got our central hub. Okay, so when we look at the propeller and hub from the top, we can see that there's an error. The hub does not align with the propeller. For this, I suggest we use the move/copy tool. I'm going to select the hubs first, then the propeller, and then deselect the hub. Now what this allows for is that it allows us to move the propeller with respect to the hub. So I'm going to move the propeller down and to the right, just until that it looks that it fits into the hub. Out one propeller blade and one central hub. Now we need to make the second propeller blade. For that, we can use the pattern tool. So the pattern tool, which we used before, now I'm going to use the circular pattern tool as opposed to the rectangular pattern tool. For my type that I'm going to be patterning or reflecting, I'll be selecting bodies and then selecting the propeller blade. For the axis of rotation, we're going to be selecting the z-axis, which is shown in blue. The z-axis is what we centered the central hub about, so select that right there. And if you look at it from the top, you already see the propeller shape. I wanted to have two blades though, so I'm going to reduce this by one. Click OK, and voila, we have a propeller. The one last thing before we go, we need to combine, because these are three separate bodies right now, so three separate parts. We want to make this entire thing one part. So for this, I'm going to use the combine tool one last time. For my target bodies, I'm going to be selecting this and that. And my operation is going to be join, and I'll click OK. There. Now we have a propeller. To fabricate this propeller, we want to first export this file. So I'll be clicking File, Export, and we will see this. So you can name the propeller whatever you want, but there's a list of files. The most common used files for 3D printing is STL, so I'll be clicking STL, and then you want to click Export. The next step is to open any slicing software that you have installed. For this, I'll be using Ultimaker Cura, as I will be printing on an Ultimaker printer. So first, I select my printer make, which is the Ultimaker S5, and we should see the printer in this virtual space. Then we should drag and drop the STL file we exported earlier into this software. And then now you can see that our propeller is placed on the bed. In this software, there are several things we can do. One thing is that we can select on our part, and we can adjust its location where you want it to print it. We can rotate it. For instance, if you want to rotate it on its side as opposed to its front, we can do that. And we have these important guidelines to the settings to the right. So this is an engineering part. And for engineering, it is important that the strength of the part is maintained, as this part is going to be holding structural loads. For that, I recommend an infill of 100%. If lightness is important and strength is not that important, you can decrease it. But for any engineering loads, I recommend a infill of 100%. And for layer height, which basically determines the quality of our prints, you should usually choose 0.1, which is one of the best, or which is the best for engineering. So once I made these, we click slice, and our propeller is now ready for 3D printing. Usually, when you have a printer on your network, the software will recognize it and it will show up and you can start to print right away. I do not have a printer, so I cannot do that. So, yeah. Thank you for listening, and I hope you have a great day.